Hello and welcome to the first tutorial series on HAROS, the High Assurance ROS framework. In this video, we will be going over some basic exercises regarding specification of behavior properties and their verification. To specify the properties, we are going to use the domain-specific HPL language, and for the verification step, we will be using a HAROS plugin for property-based testing. When given a testable property, this plugin will automatically generate a number of tests in order to try to find a counterexample. The setup for these exercises is basically the same as in previous videos. We assume the use of the Docker image and that you follow the necessary steps to extract architectural models. So moving on to the introduction. Properties are given in the HAROS project files, and they are always relative to a specific system or node. We have some simple examples here showing the structure of the properties and how they are specified. Properties are relative to a topic and the messages exchanged in this topic, and they are based on patterns, like saying that there should be no messages of a specific format or that one message leads to another. So one thing to note with this plugin and this verification technique is that it is going to take a significant amount of time when compared to other types of analysis. By default, the tests are only generated to be executed at a later time. If you want to execute them during the analysis, we have to specify a few additional settings. With that said, it's time to go into the first exercise, which will require us to be familiar with the safety controller node. This is a node that publishes velocity messages and emergency stop commands in response to the sensors, but the messages are only published once every few seconds so as not to spam the driver with messages. As we can see here, the bumper messages receive an emergency stop in response. Laser messages publish a velocity command of 0 for values of 64 or lower, and an emergency stop for values of 32 and lower, while wheel drop messages receive emergency stop in response. Now we've got here some hints and explanation on how to write a property for this kind of behavior. And we can see here in the exercise instructions that the property should be false. The safety controller has a bug. So our first task is to open the Fictibot project file, write down this property for the safety controller node, and run the tests to see what HAROS has to report. So I'm going to start by copying the node specification into the project file. We can see here that the property is annotated under the node. And now we are ready to run the analysis, which should take a while to complete. I'm going to skip ahead to the visualizer directly when it finishes. So here we are. The analysis has completed. I'm refreshing the visualizer and jumping to the runtime issues of the safety controller node. And there we go. We have here the first issue report saying that a property-based test failed with the counterexample. The counterexamples are basically sequences of messages or traces that, when replayed to the system, lead to the property being false. In this case, the property-based testing plugin sent a message on the laser topic more or less 2 seconds after starting the system, and with a data field with the value 0. Recall that we are testing laser messages with values below 32, and 0 in particular is a good example. So if we now look at the code of the safety controller to see what happens with a value of 0, we can see that indeed the implementation is wrong. It's always sending the slowdown message instead of the emergency stop when values are below 32. In this case, the developer forgot to implement the special case. So let's go ahead and do it ourselves. Let's find the safety controller node in the source code and navigate to the laser callback. And then simply add a special case for values below 32 that send an emergency stop. All done, the next step is to run catkin again to make sure that everything compiles. And in this case, compilation is necessary because we are running tests and we need an up-to-date binary executable of the code. Everything seems to compile. And that concludes the first half of this exercise. Let's move on to the second part, which tells us to rerun the analysis and gives us a fair warning that the tests should take a lot longer to run now, because the implementation is closer to the ideal, so the plugin takes a lot more effort to find something that goes wrong. Again, I'm just going to skip ahead to the end of the analysis. And here we are again. Let's refresh the visualizer and confirm that we now have a new counterexample for the property with 2 messages. The first one is considered spam because it is not strictly necessary by the pattern of the property, but it is necessary to trigger the counterexample. And in this case, has to deal with that part of the documentation that says that the safety controller only sends a message once every t seconds. If we look at the source code, we can see that there are some early return clauses here, some timers going on to implement these once every now and then behavior. And we can see that the default time for this once every now and then behavior is 1 second. So the safety controller will never send messages more often than once per second. So what's happening here is that the plugin basically sent 2 messages very close to one another. The property says that every message should have its response, and obviously this is not true because we have this intermittent behavior going on. So what we are witnessing is basically a specification error. The property is too strong and it does not reflect exactly the kind of behavior that we are trying to go for with this safety controller node. Unfortunately, there is no way to specify this exact behavior in the current version of the language, so there is no direct action to be taken in this exercise. This is just to demonstrate the limitations of the current approach. And with that said, let's move into the final exercise. This time we want to verify that in the random controller node, a bumper message with any of its fields triggered leads to a new velocity command being published. But as we will see, this property is also false. So let's go ahead and open the project file and specify the new random controller node with this property and see what's going on. I'm going to just enable tests for this random controller because we already ran the tests for the other node. Let's copy the property and see if we get the counterexample. Again, I'll skip ahead to the end of the analysis. We are back. The analysis has concluded. Let's refresh the visualizer, check the issues for the new random controller node, and there we go. Here we have the counterexample with two messages. We can see that both messages go on the bumper topic, and one has one field set to true and the other has the same field set to false. They are sent one right after the other, almost instantaneously. And if we look at the source code, we can see that the system is vulnerable to this kind of message overwriting that's going on. So it's basically storing values from one message to the next iteration of its main loop. And what's going on is that two messages come one right after the other. They overwrite the values before the system has a chance to run its next iteration in the main loop. So basically the value is set to true, then again set to false, and once the system gets back to its main loop, it's like the true message never happened in the first place. Is this a problem? How do we fix it? Well, it's not necessarily a problem. In this case, the messages are so close to one another, so quick, that it might as well just have been sensor noise or something along those lines. It's an obstacle, but it's already cleared right after, so it's probably not worth sending the new response for this particular random controller. So once again, this is one of those cases where there might be no specific solution for the exercise. It's left to the developer to choose whether to modify the node's behavior or simply accept that the property isn't specifying exactly what the intended behavior is. The point is that there is a counterexample for the property. Whether or not it is a real problem in the system is left for you to decide. The exercise provides some suggestions to alter the controller node behavior. And with that, we have reached the end of this tutorial track. Stay tuned for more videos.